quick review on energy. Again, this isn't going to be very comprehensive, and we're not going to really see a lot of the mathematics, but just kind of an overview of some of the different keywords that we need to know about. So work is essentially any time a force gives or takes energy away from the object. Work can be done by all kinds of different forces. It can be done by gravity. When something falls, that is gravity doing work. It can be done by friction. A block is sliding, and that block is losing energy over time. Its kinetic energy is decreasing as its velocity is decreasing because there's work done by friction. Work is a scalar, even though it is based upon two vectors, force and displacement. Those two vectors are manipulated in a fashion that makes work a scalar. Theta, cosine of theta. Theta is the degrees between the force vector and the displacement vector. This is an overview for energy. The units for energy and for work are in joules. This is also known as a Newton meter, although Newton meter is typically reserved for torque because torque does not translate into joules unless you have a delta theta with it. So for the most part, use joules as the unit for energy so we can distinguish it from torque. Other things you may have heard of energy is the calorie and the electron volt. And the energy unit for the AP Physics courses, they focused on three types of energy: kinetic energy, gravitational potential energy, and spring potential energy. Kinetic energy is energy of motion. This is the one that always has to be greater than or equal to 0. Mass is always positive. Velocity, positive or negative, doesn't matter. It gets squared, and therefore it is greater than or equal to 0. Now that v squared is a key component of kinetic energy, and it's a key component because of how squaring numbers works. So for example, if I went from 0 to 10 miles an hour, 10 squared is 100. Then if I went from 10 to 20 miles an hour, 10 squared is 100, 20 squared is 400. So by doubling the speed, I've actually quadrupled the amount of energy, and it's all due to the v squared. The other type of energy is potential energy. There were two of them, gravity and spring. Potential energy is abbreviated with the letter U with the subscript of G or S, depending on which one. Now, the gravitational potential energy is due to your location on Earth. It can be positive, it can be negative, it can be 0. In general, no one really cares about potential energy for gravity. They only care about changes in potential energy, and that's why you were taught the strategy of setting the height to be 0 where you wish, and then basing potential energy values off of that. Because ultimately the potential energy translates into kinetic energy, or the kinetic energy translates into potential energy. And obviously work done by friction does tend to take up some of it. The spring potential energy is just like kinetic energy, is greater than or equal to 0 because k is always a positive number and the displacement is squared. So it does not matter if you stretch the spring or you compress the spring. If you stretch it 20 centimeters, that's the same amount of stored energy as compressing it 20 centimeters. Now, that spring energy stored in the spring typically gets released into kinetic energy, or if we're talking vertical, a combination of both kinetic and potential energy. On a vertical problem, it's important to think about if I take a block and I set it on top of the spring, squishing the spring downwards, and then I release it, that block gains elevation, which is a gain in gravitational potential energy, and it gains speed, which is a gain in kinetic energy. So vertically for springs, a vertical spring is going to, as it releases that energy and pushes the block upwards, give it both simultaneously potential and kinetic energy. Done horizontally, the spring would give it ideally only kinetic energy. And next one will be momentum, obviously.